In this episode, we're going to look at how to configure PAT. I'll show you how to do it, and we'll talk about the concepts along the way. We'll be discussing configuring and verifying dynamic network address translation with overload. We'll look at configuring port address translation using an interface, and then finally, we're going to verify PAT interface implementation. Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Packet Tracer Lab 6.6.7 Configure Port Address Translation. I have our Packet Tracer Lab opened up. On the left side, I have the Packet Tracer window where we have our topology, where we can do our configurations. On the right side, I have our instructions. On the very bottom right, I have the Packet Tracer activity window that opens up with the instructions when you open up Packet Tracer. On the upper right, the majority of the right side, I have a Word document of those same instructions. The Word document allows me to answer the questions, save my answers. What we're going to do is we're going to look at dynamic NAT with overload here. We're going to verify that and then configure PAT using an interface. Part 1, configure dynamic NAT with overload. So configure traffic that will be permitted. How we do that is with an ACL. On router 1, configure one statement for ACL1 to permit any address belonging to the 172.16.0.0/16 network. So over here on R1, I'm going to go ahead and click on R1. I'm going to make the window a little bit bigger, going right to left. Hit enter, no password, so I can go ahead and type enable. Now, to configure the traffic that will be permitted, it's an ACL. To configure our ACL, we need to be in global configuration mode, so go ahead and type config T. And then from here, it's just configuring a standard numbered access list. Do that, we type in access-list, then the number of our list, which is number 1, and we are going to permit traffic from the 172.16.0.0 network, and now we have to put in the wildcard mask. We are given the subnet mask of a /16. The subnet mask, to get the wildcard mask, we invert it. We change all the ones to zeros. So the subnet mask is 16 ones followed by 16 zeros. Invert all the ones and zeros. For the wildcard mask, that gives us 16 zeros followed by 16 ones, or 0.0.255.255. So after you put your network address of 172.16.0.0 in there, we can put our wildcard mask of 0.0.255.255. Part 1, step 2, configure a pool of addresses for NAT. So on R1, configure a NAT pool that uses 2 usable addresses on the 209.165.200.232/30 network. Well, with a subnet mask of 32 bits, the 232 is actually a network address. So 232 is actually a network address. With a /30, that you get 4 IP addresses, but you can't use the first one. That's the network address. Can't use the last one. That is the broadcast address. So that only leaves us with 2 usable IP addresses. And that's what our requirements are. So the usable IP addresses would be .233 and .234. Let's go ahead and create that NAT pool. To do that, we start off with IP NAT, and then we are doing a pool, and then we give it a name. It doesn't matter on the name, but the name you use here, you have to then use when you correspond the access list to the pool. And so let's go ahead and just call it NAT pool. Now, the name is case sensitive and punctuation sensitive. Standard convention is you give your pool name all capital letters, so that way it stands out, easily identifiable. So my pool name is capital N, capital A, capital T, underscore, capital P, capital O, capital L. NAT underscore pool, all capital letters. So that's the name of our pool. Then we put it in our Oh, then we put in our, start over there. Then we put in our first IP address. Once again, that was 209.165.200.233. We put in our ending IP address, and we only have 2 of them, so it's one more up than that, which is 209.165.200.234. Have the starting IP address, net ending IP address. Then all we have to do is put the network mask in there. So we go ahead and type in net mask, the keyword, and then a /30. Turn that into dotted decimal notation. That is a 255.255.255.252. That creates our pool. Now, we have our access list created, access list 1. We have our NAT pool called NAT pool created. Now we need to associate those 2 together. And that's what step 3 is. Associate access control list 1 with NAT pool and the allowed addresses to be, and allow addresses to be reused. Okay, to be reused is a key part. But to associate them together, we start off with IP NAT inside source list, and then the number of our access list, which was access list 1, and then the keyword of pool, and then our pool name. Once again, our pool name was capital N, capital A, capital T, underscore, capital P, capital O, capital L. And now, to be reused, this is where we put the keyword of overload in here. We put the keyword of overload. That associates access list 1 with the NAT pool, and then we're going to be overloading it. We're going to be reusing those addresses. On to step 4, configure the NAT interfaces. So now we have to say which is the outside, which are the inside interfaces on our devices. Now, this is something you can do. You can have multiple inside interfaces, and that's what we're going to do here. So both of these networks will be able to use NAT here. And so both the gig 00 and the gig 01, those are going to be inside interfaces. And then our serial 010, that's going to be an outside interface. Now, to do that, we have to go into the interface itself and then say, are you an inside or outside for our NAT? So from global configuration mode, let's go into our serial interface. So interface serial 0/1/0. We are now configuring that serial 010 interface. That is our outside interface. Now to set that up as our outside interface, simply type in IP NAT outside. Then we go in and we start doing the gig. We can type in interface G 0/0/0. And we can say that this is an IP NAT inside interface. And we do the same thing for the gig 001 interface. Change to the interface of G 0/0/1 and then do IP NAT inside. We now set up 2 interfaces as our inside for the one outside. Okay, I'm going to minimize the R1 window here. We're on to part 2. Verify dynamic NAT with overload implementation. Access services across the internet from a web browser of each of the PCs that use R1. So these are each of the PCs here that use R1, PC1, PC2, laptop 1, laptop 2. Access the web page on server 1 where the connection's all successful. So I'm going to go ahead and open up PC1 here. Open up my web browser app. I had to make the window a little bit bigger, but let's go ahead and enter in the IP address of our server, which is 209.165.201.5. So 209.165.201.5. And here's our web page. So PC1 could connect. I'm going to go ahead and minimize that. Open up laptop 1. Same thing. Open up my web browser app. Put in the IP address 209.165.201.5. Here's the web page for server 1. We are accessing that. Here, click on PC2, slide that up, make the window a little bit bigger so I can see my web browser app. Click on that. Put in the IP address for server 1, so it's 209.165.201.5. Here's the web server for the web page for server 1. And finally, let's check laptop 2. Put in our IP address 209.165.201.5. And there's our web page. All 4 of those devices were able to access the web page. Once again, we only had 2 addresses in our NAT pool, but we're able to reuse them. We are able to use that overload in our IP NAT statement to reuse those IP addresses. So were the connections successful? Yes, they were. Step 2, view NAT translations. View the NAT translations on R1. So I'm going to click on R1 here. To view the IP NAT translations, we need to be in privileged exec mode. I'm going to type exit once, takes me to global configuration mode. Type exit a second time. I am now in privileged exec mode. I can go ahead and enter in show IP NAT translations, and there's our translations. Notice the inside local 172.16.10.11. It's either PC1 or PC2. 172.16.10.10. Once again, either PC1 or laptop 1. The third octet signifies that they were from this network right here. Then the other translations, 172.16.11.10. So the third octet is different, signifying they belong to this network. And the fourth translation is 11.11, once again belonging here. So all 4 of these were able to use those 2 addresses. Then our inside global address, those were the addresses from the pool. And if we notice here, we only actually used one of those IP addresses. We used the first one. We only used the .233 address. We never used the .234 address. And of course, our outside local and our outside global address is the IP address of our web server. I'm going to minimize R1 here. On to part 3. Configure PAT using an interface. Configure traffic that will be permitted. On R2, configure one statement for ACL2 to permit any addresses belonging to the 172.17.0.0/16 network. So on R2, make the window a little bit bigger, right to left, log in, type enable to get into privileged exec mode. First thing we have to do is set up our ACL. We do that in global configuration mode. Go ahead and type config T. Now we can go ahead and set up our access list. So we start off by typing in access-list. We're doing access list 2. And then we are permitting, and then the network address 172.17.0.0, and then the wildcard mask. Same wildcard mask we used earlier. Subnet mask is /16, so 16 ones followed by 16 zeros. Invert that gives us then 16 zeros followed by 16 ones, which then translated into dotted decimal notation is 0.0.255.255. So that is our access list there. We only need one statement. And of course, I spelled access wrong. Cisco was kind enough to tell me. Up arrow, left arrow over, fix the word access, hit enter. Now, how do we know I did it correctly? No news is good news. If I did everything correctly, Cisco won't let me know. If I screwed it up, Cisco will definitely let me know. We created our access list. Now we need to create our pool. Step 2, associate ACL2 with the NAT interface and allow addresses to be reused. Enter the R2 NAT statement to use the interface connected to the internet and provide translations for all internal devices. Now, the interface that's connected to the internet is serial 011. It's serial 011. And so, enter the statement to use the interface connected to the internet and provide translations for all internal addresses. Now, we start off here. We are still in global configuration mode. We start off with IP NAT inside source, and then list is our access list, so that's number 2, and then we tell it what interface. So interface, and once again, this interface we're using is serial 011 here, so we can go interface space S0/1/1, and then once again we are overloading it because we're going to have one address to supply all the internet connectivity to all of our internal devices. And so we put in the word overload. Okay, making sure I type my command in right. Hit enter. That then set it up. Next thing I need to do is step 3 here, configure the NAT interfaces. Configure R2 interfaces with the appropriate inside and outside NAT commands. Once again, on this one, we're going to have 2 internal interfaces, gig 000 and gig 001. They're going to be my inside addresses, and serial 011 is going to be my outside addresses. To do that, we have to go into the interface. Let's go ahead and do our serial interface first. So from global configuration mode, I can go ahead and type interface serial 0/1/1. Now configuring that interface, and we can say IP NAT, and then outside, because that is our outside interface for our translations. Then we can go ahead and do gig 000 and gig 001. Let's go ahead and do gig 00 first. You could type exit and then type interface gig 001, or you can just type in interface and then G0/0/0 right there. And now we're configuring that interface. And so we're going to say IP NAT, and then once again, this is an inside interface. So inside, IP NAT inside, that's gig 00 is an IP NAT inside interface. And then let's change to interface of gig 0/0/1. Oh, I forgot a slash in there. Interface G0/0/1. And then once again, this is another IP NAT inside interface. I'm going to go ahead and minimize that for a second. That takes care of part 3. On to part 4, verify PAT interface implementation. Okay, so from the web browser on each of the PCs that uses R2, that would be these PCs here, PC3, PC4, laptop 3, laptop 4. Access the web page for server 1. Were all connections successful? Okay, let's go ahead and open up PC3. Get into our web browser app. Put in the IP address here of our web server, 209.165.201.5. There's our web page for server 1. Go ahead and minimize that. Go into laptop 3. Go into our web browser app. Put in our IP address of 209.165.201.5. There's our web page for server 1. Go ahead and minimize that. PC4, same thing. Go into our web browser app. Put in the IP address 209.165.201.5. There's our web page for server 1. And finally, for laptop 4. Open up our web browser app and put in our IP address of server 1, 209.165.201.5. And there it is. All 4 of our devices connected into server 1. So were all the connections successful? Yes, they were. Step 2, view the NAT translations. View NAT translations on R2. Now to do that, what we do is go into R2, go into privilege exec mode. Currently we're configuring an interface. Type exit once, that brings us to global configuration mode. Type exit twice, that brings us into privilege exec mode. Then we can go ahead and type in show IP NAT translations, and that gives us our translations. Once again, the inside local addresses here are the IP addresses of PC1, PC2, or sorry, PC3, PC4, laptop 3, laptop 4. Our inside global address is the IP address of our outside interface, 209.165.202.130. And our outside local and outside global, those are the IP addresses of our web server. Compare the NAT statistics on the 2 devices. So here is R2. I'm going to pull up R1 here. Log in quickly, get into privilege exec mode. Type in show IP NAT translations. And our question reads, why doesn't R2 list any dynamic mappings? The show IP NAT translation command really doesn't give us any information about our dynamic mappings. What we need to look at is the show IP NAT statistics command. Here, it'll give us some information about our pool. It'll give us information on our dynamic mappings, which include that pool addresses. If I go to R2, enter in that same command, show IP NAT stats. Once again, spell stats correctly. Notice here, we have no dynamic mappings. On R2, we have no dynamic mappings. On R1, we have dynamic mappings. Now, reason for that is on R1, we have that pool of addresses, so they dynamically can map those. On R2, we don't have that pool. We only use that outside interface as the address to be translated. So there is no dynamic mapping happening. Okay, so for our answer, R1 lists dynamic mappings for the pool of addresses that has been configured. R2 is only using the outside interface as the address to translate addresses to, so there is no dynamic mapping. Okay, do some quick spell correcting here. That completes our lab. That was Packet Tracer Lab 6.6.7, Configure Port Address Translation. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.